Welcome to my channel R Classes. Today I am taking up the topic Quantitative Techniques, wherein introduction part of Quantitative Techniques will be covered. The points which are to be covered are decision making and quantitative techniques, historical development of operations research, nature and characteristics features of OR, methodology of operations research, linear programming problems, formulations of LPP, and assumptions underlying linear programming problem. Decision making and quantitative technique. As we know that decision making is an integral part of the management process. It is said that decision making refers to making choice among the alternatives available. If no alternative is available and somebody claims to be taking a decision, fundamentally speaking, he is wrong. Because if only one option is available, it is not that you really took a decision. Rather, if you have managerial capability in you, you must be able to generate alternatives and then make a choice from among those alternatives. Then that is known as decision making. Though here I am not going into the theoretical aspect of literally the decision making, rather here the topic is decision making from quantitative viewpoint. Managerial or business decision making is basically a process by which a manager representing a management chooses a specific course of action from a set of possible options. The decision maker attempts to choose the most effective course of action in the given circumstances in attaining the goals of the organizations. Now I'll talk about the different types of decision making situations. There are normally, say, uncertainty. There are chances where decisions are static or in static conditions, and the decisions one has to take in view of the nature's role into play, means where the involvement of nature is there, or you can say the opponent is your nature itself. As far as decision making under uncertainty is concerned, decision making under uncertainty, where all facts are known fully and for sure, are termed as taking decision under certainty. But if situations or the facts and figures are uncertain, then we can say that it is the decision making under uncertainty. As far as static decisions are concerned, decisions for one time period only called static decisions, or a sequence of interrelated decisions made either simultaneously or over several time periods called dynamic decisions. As far as decisions where the opponent is nature is concerned, here the rational opponent is basically the nature itself. Decisions where the opponent is nature, say for example construction of a bridge over a river, digging an oil well, etc. In such cases, managers are to take decisions in view of the nature's role as to what are the climatic conditions and other conditions existing on the ground. Now we'll talk about there are certain elements, important elements, which are which play a major role in taking a decision. The first is that the decision maker himself. The decision maker could be an individual or a group or an organization, an association of persons or society. Second is a set of possible actions. A set of possible actions that may be taken to solve the decision problem. A set of possible states that might occur. A set of possible consequences. Here we mean by the payoffs associated with the various combinations of courses of actions and the states that may occur, and the relationship between payoff and the values of the decision maker. Now here we will talk about that how this quantitative approach, that means things, rather the facts and figures related to that particular problem, how do they help in quantitatively making a decision. Actually, quantitative approach is basically one of the important and most quantifying approaches. The central idea of the quantitative approach to decision making is that the factors that influence the decisions can be identified and quantified, then it becomes easier to solve the complexity of the tools of quantitative analysis. In fact, a large number of business problems have been given quantitative representation with varying degrees of success, and it has led to a general approach which is variedly designated as operations research or management science or systems analysis or decision analysis and so on. Quantitative analysis is now extended to several areas of business operations and represents probably the most effective approach to handling of some types of decision problems. Now we'll talk about the historical background of operations research, or you can say quantitative techniques. It is more when it came into being as a concept, it was known more as operations research. Though there is no clear history that makes the birth of OR, but it is generally accepted that the field of OR originated in England during World War II. Operations research as it exists today came into being only during the World War II. Military management during the wartime called upon a group of scientists to examine the strategies and tactics of various military operations with the intention of efficient allocation of scarce resources for the war effort. During this period, many new scientific and quantitative techniques were developed to assist the military operations. The name operations research was derived directly from the context in which it was used. The research activity on operational areas of armed forces led to a great success, and the success of this operations research during World War attracted the other persons in other different walks of life, say industrial or business field. Since then, the industries people and the business persons started making use of the operations research. After the World War, operations research was developed by the industry, and some of the techniques that have been applied to solve the complex industrial problems. So that made it basically a discipline, and since then it is now treated as a subject, a discipline in different universities, not only the United States or the European countries, but also in India. It came in 50s only in India, and the universities started accepting it as a discipline. As far as definitions of OR is concerned, a lot of statements are made in the name of OR. It is said that it is nothing but a scientific common sense. It is a process of giving bad answers to the problems which otherwise have vast solutions. Somebody said operational research is a systematic and analytical approach to decision making and problem solving. OR is an applied branch of mathematics that uses techniques and statistics to arrive at optimal solutions to solve complex problems. It is typically concerned with determining the maximum profit, sale output, crops yield and efficiency, and minimum losses, risk, cost, and time of the objective function. Now we'll talk about the nature and characteristics of OR. There are basically 5 points which characterize the nature and characteristics of OR. The first one is decision making. As since the beginning of the topic, it is being emphasized that this is one of the features of operations research. OR is addressed to the managerial decision making or problem solving. A major premise of OR is that the decision making, irrespective of the situation involved, can be considered as a general systematic process that consists of certain points as stated. First, define the problem and establish the criterion which will be used. Second, select the alternative courses of actions for consideration. Third, determine the model to be used and the values of the parameters of the process. Evaluate the alternatives and choose the one that is optimal. Optimality is of utmost importance in operations research. Optimality never talks of the best or the worst, rather, it is the best course of action within the given constraints. It never talks of the ideal situation. It is the best course of action within a given situation or constraint. It is highly scientific in nature. This is why scientific approach is also one of its features. It employs scientific methods for the purpose of solving the problems. Certain steps are to be taken care of here. First, the problem to be analyzed is defined clearly and the conditions for observations are determined. Observations are made under varying conditions to determine the behavior of the system. On the basis of the observations, a hypothesis describing how the various factors involved are believed to interact and the best solution to the problem is formulated. To test the hypothesis, an experiment is designed and executed. Observations are made and measurements are recorded. Finally, the results, the experiments are analyzed and the hypothesis is either accepted or rejected. So that's how it is highly scientific in nature. It is said that every action has got its purpose. So this is why operations research always works on objectives. It does have its own objectives. OR attempts to locate the best or optimal solution to the problem under consideration. For the purpose, it is necessary that a measure of effectiveness be defined which is based on the goals of the organization, that is the objective. It is interdisciplinary team approach. Not only one person can do all. Nobody can be having complete knowledge about all the subjects involving in a particular situation, because it largely deals with the industrial or market in organizational problems, wherein persons from different fields, may mathematicians or psychologists or other different disciplines, are involved. Rather, it requires a good blend of people with expertise in the different areas as stated, like statistics, engineering, mathematics, economics, management, computer science, etc. Because it deals with huge amount of data, so this is why it requires the a computer. A digital computation is the need of the hour to solve the different problems falling under operations research. Now we'll talk about the methodology of operations research. Very clearly, first is formulate the problem. Formulating the problem, that is the first step in the quantitative analysis to develop a clear and concise statement of the problem. Formulating the problem means identifying the decision variables, constraints, and identifying the different constraints in detail and designating them as clearly, say some in some symbolical algebraic figures. Then we can make a mathematical framework in a special manner that may be termed as mathematical model or model building, wherein the objective function is there. Constraints are expressed in mathematical form as linear relations, and we have the alternative solutions. So it has got a typical format which will be shown to you, expressed to you in the following slides. After the mathematical model is built up, we acquire input data so that the solution can be arrived from that particular model. Once an appropriate model is formulated, that is the step wherein the input data are put and tested. Next step is solving the model formulated and interpreting the results. After we have interpreted the results, then we try to validate the models. The validation of a model requires determining whether the model can adequately and reliably predict the behavior of the real system that it seeks to represent. And the last one is, that is, implement the solution. The final step is the implementation of the results. It is the process of incorporating the solution in the organization. Implementation of solution is often more difficult than it may apparently seem. Now we will talk about the linear programming problems. As we know that those objectives, decision variables, whatever we discussed, they are to be expressed in mathematical functions. They are termed as linear programming problems. Linear programming method is basically a technique for choosing the best alternative from among a set of feasible alternatives available in situations in which the objective function as well as the constraints can be expressed as linear mathematical functions. A linear programming model seeks to maximize or minimize a linear function subject to a set of linear constraints. There are certain points must be kept in mind while formulating the problem as a linear programming problem. First, there should be an objective which should be clearly identifiable and measurable in quantitative terms, as has been discussed in previous slides. The activities to be included should be distinctively identifiable and measurable in quantitative terms. The resources of the system which are to be allocated for the attainment of the goal should also be identifiable and measurable quantitatively. The relationships representing the objective as also the resource limitation considerations represented by the objective function and the constraint equations or inequalities respectively must be in linear in nature. There should be a series of feasible alternative courses of actions available to the decision maker that are determined by the resource constraints. Now we'll talk about process of formulating LPP. The basics of formulation have already been covered there in previous slides. But as I was talking about that mathematical formulation or mathematical model is a kind of special arrangement in which there are 3 parts rather should be there. The first one is the objective function. The first major requirement of an LPP is that we should be able to identify the goal in terms of the objective function. This function relates mathematically the variables with which we are dealing in the problem. The second part is that is the constraints. It is a requirement of LPP that the resources must be in limited supply. The mathematical relationship which is used to explain this limitation is inequality. The limitation itself is known as a constraint. And then non-negativity condition. It is very important in formulating a problem in LPP. The decision variables cannot have negative values. The variables can assume values only greater than or equal to 0. This is the non-negativity condition expressed symbolically as say x1 or x2 greater than or equal to 0. A typical mathematical formulation or LP model formulation is represented here in this slide, wherein the objective function is written as maximum or minimum, whatever be the case, symbolically z. So maximum or minimum z may be equal to say c1x1 plus c2x2, cnxn, etc. Then constraints, subject to constraints, those constraints are expressed as inequalities. Inequalities may be of less than or equal to or greater than or equal to type, and the alternative solutions must be written there as x1, x2, etc. greater than or equal to 0. A typical mathematical model here in further slide is shown here. So there are certain assumptions of LPP. We need to understand it first. Say assumption of proportionality. A basic assumption of linear programming is that proportionality exists in the objective function and the constraint inequalities. We also assume the additivity. It assumes that the objective function and constraint inequality is both. The total of all the objectives activities is given by the sum total of each activity conducted separately. Continuity. It assumes that decision variables are continuous. Certainty. It assumes that the various parameters, namely the objective function, coefficients, the coefficients of the inequality or equality constraints, and the resource values are known with certainty. finite choices, a limited number of choices are available to a decision maker, and the decision variables do not assume negative values. Now, to make you completely understand, here I have taken a mathematical problem, an example wherein a firm manufactures two products A and B, on which profits earned per unit are rupees 3 and rupees 4 respectively. Each product is produced on two machines, say M1 and M2. Product A requires 1 minute of processing time on M1 and 2 minutes on M2, while B requires 1 minute on M1 and 1 minute on M2. Machine M1 is available for not more than 7 hours and 30 minutes, while machine M2 is available for 10 hours during any working day. Find the number of units of products A and B to be manufactured to get the maximum profit. So this is the problem, that in language form it is written. Otherwise, normally you will get the problem already formulated. Here we will learn how to formulate the problem. As I told you, that first you go to the problem, identify the decision variables, and you can, in raw form, you can note down the variables here as shown by assuming that let x1 and x2 be the number of units produced of the products A and B respectively. Then after, just note down in this some matrix form here, say like A and B, now for machine M1, machine M2, and profit and availability of the resources. That way, as you are seeing here, you can note it down, and then you can finally formulate the problem as maximum z is equal to 3x1 plus 4x2, subject to constraints. We normally write in short form as stc dot, wherein here you see x1 plus x2 is less than or equal to 450 minutes and 2x1 plus x2 is less than or equal to 600 minutes, x1 x2 greater than or equal to 0. So this is the typical mathematical formulation. I hope that you have all understood it clearly, and I have tried my level best to make the topic so interesting, so easy for you. So for any query, if you should have any query, you can write to rclasses@gmail.com. For more video tutorials on quantitative techniques and operations research, you can click on my YouTube channel R Classes. The link is given here. And for your interest, I have put some thumbnails of the videos already put on my channel, so you can also watch them. Thank you very much for watching me so patiently. If you have liked it, so please like the video, share it, and subscribe it. Thank you very much. Have a nice time. God bless you. Thank you.